All right, hey everybody. Yeah, you guys have your quiz when you come back to school on Tuesday. It's Sunday night now, so I wanted to get these videos up. You guys will have all of Monday to go over them. Um, and if you have any questions, you could leave them in the comments. You could email me. You could do a lot of stuff to try to get some help, talk to each other, whatever you need. But Tuesday is our quiz, so let's get ready. What you're looking at right now, just a couple more examples. You guys don't have these anywhere. But I wanted to point something out because I saw some people making a mistake with this, just labeling which side is which, opposite, adjacent, hypotenuse, all that good stuff, right? So looking here, a lot of people think that your triangle is always going to look like, the first and the second, where you're always going to have two legs, a vertical leg, a horizontal leg, and it's not always going to be like that. I think that should probably be our third option. And then this fourth option is our trickiest. But I think a lot of people do just fine when you've got the first or second option, because you can find your angle. Okay, here's your angle. Opposite means across the triangle. That's your opposite side right there. Then your hypotenuse is across from the 90-degree angle. So there's your hypotenuse. And that only leaves this one to be adjacent. So I think people get it in their heads that the opposite and adjacent sides are always vertical and horizontal. The hypotenuse is always the diagonal one. That's not true, right? For this one, it's still true. We can see, okay, my angle was down here before, so the opposite side was vertical. Now that my angle is up here, the opposite side would be the horizontal one down here. The adjacent side would be here, this vertical one. And the hypotenuse would be diagonal. So people start thinking hypotenuse is always diagonal. But all I'd have to do is tilt the triangle just a little bit. Now everybody's diagonal, right? Nobody's horizontal. Nobody's vertical. So you really have to remember the positions. Opposite means across from. So go to the angle and think about like an angle bisector, shooting between the two sides of the angle. It'll always point you to the opposite side. Then your hypotenuse is always right across from the 90-degree angle. And your adjacent side would go here. And then the orientation that I think is trickiest is this, because look, we've kind of set the triangle so that the hypotenuse is the bottom of the triangle, it's the base. And you don't see that often, but you do see it sometimes, and so I want to really just make a big deal about that. That sometimes the hypotenuse is actually horizontal or vertical, it could be whatever. You have to think about positions. It's about opposite. It's about being next to or across from. So again, for theta here would go across. Here's the opposite side. And that must mean that the adjacent side is here. But hopefully this is not anything that's still a problem for anybody. You guys can all figure out who's opposite, who's adjacent, who's hypotenuse, I hope. And if you can't, here's 12 practice problems. I gave you this on a whole sheet. So we're looking now at the packet of sheets that I gave you guys the other day. It's not the packet. I'm not actually assigning any homework from that homework packet because I said I didn't like it. I told you guys that. I hope you haven't been working on it. Some of you have. Some of y'all need to listen because I said that those problems were too tough. So the homework I'm talking about is the one that just, you had a sheet. The front side said page 1. The back side said page 2. Then you had a second sheet where the front side said pages 3 and 4. So there's 1, 2, and 3 and 4. That's the first homework assignment. And all you had to do here is label which side is which. So I'm going to do it. I'll probably just do it really fast. I might not even talk through it. I might just label them, and you guys can just check your work, make sure you've done it right. But if this is our angle, then opposite would be over here. Then this guy's adjacent. This guy's hypotenuse. That's it. Now here's another triangle that's like flipped around, right? I think that's important to see the triangle spun around, rotated, reflected, whatever we got to do to try to shake you guys a bit to make you see that the hypotenuse could fall anywhere, right? The opposite could be anywhere. So that's it. You find your angle. Here's opposite. Here's adjacent. Oops. This is hypotenuse. I'm just going to do the rest now real fast. So hopefully you guys agree with all that. Here's the next 4. Again, if you haven't done it yet, do it. right? Try it right now. Don't just be here copying me. Try it yourself if you haven't already done it, and then check your work with me. If you guys don't do it yourself, you'll never ever learn. So anyway, let's do these ones. That's it for those four. I hope you agree with me again. Let's do another batch. So here's four more. Again, do it yourself if you haven't already. Numbers 5 and 6 are nice because they basically look like the exact same triangle. The only thing that's changed is that reference angle. Here, if I'm referencing this angle up here, then the vertical side here is opposite. But down here, we're referencing off of this angle now. So the opposite side is this horizontal one. So that's a pretty good illustration of how the angle that you're referencing completely changes who's opposite and who's adjacent. Now notice, even though I changed angles, this is the hypotenuse of this triangle, and this is still the hypotenuse of this triangle. So changing the acute angle that you're looking at doesn't change the hypotenuse, because the right angle is still sitting where the right angle sits, so it's still going to be that same side. So anyway, that's opposite, so this must be adjacent. This is opposite, so this must be adjacent. And then we can do these ones. Kind of the same deal. Opposite is over here. This guy is going to be adjacent. Hypotenuse is down here. For this triangle, the hypotenuse is up here. Opposite would be over here. And adjacent's right here. So there's 12 examples of how to just decide which side is opposite, adjacent, and hypotenuse. Obviously that's super important. If you remember any trigonometry at all, then you know that we're about to start using SOHCAHTOA a whole bunch. And if I'm asking you for the value of the sine of an angle, then yeah, SOHCAHTOA will tell you that you just want to be giving me the opposite side divided by the hypotenuse. But if you can't figure out which side is the opposite side, then you're going to give me the wrong side, you're going to give me the wrong fraction, you're not going to get credit. So being able to decide which side is which is like, that's the foundation of everything. That's why I spent so much time talking about this. 7 minutes, 8 minutes apparently. And yes, I probably could have been able to just say it once, and many of you would have been fine. But you know, no harm in me talking for a while. Just fast forward if you don't feel like listening to me. Alright, so here's some actual problems. You're being asked here to actually find the sine of angle C. So the sine of angle C is just going to be some fraction, right? Anytime you're doing a trigonometric function of an angle, you're just going to get a fraction where the numerator and denominator are both just sides of the triangle. The only real trick for you is to figure out which sides, right? So for C and for sine, sine always wants opposite over hypotenuse. So for this triangle, that would be 21 over 29. So this fraction is your answer. Normally we would reduce, but 29 isn't divisible by anything. It's only divisible by 29 and 1. And you can't divide 21 by 29. So leave that alone. Now over here, they're asking for the sine, again, of C. But in this triangle, here's C. The opposite side is 30. The hypotenuse is the 50. Now this time both of these numbers are divisible by something. They're both divisible by 10. So dividing by 10 gives 3 over 5. So you must reduce your answer to simplest form, or you're going to lose partial credit when you take your quiz. But that's it. There's two examples of sine. Now this one switches gears and wants cosine. And again, we know from SOHCAHTOA that every trig function is a fraction based on two sides at a time. We can see that sine will always be opposite divided by hypotenuse. Cosine will always be adjacent divided by hypotenuse. And tangent will always be opposite divided by adjacent. So if I'm doing cosine, then I know that this time what I'm after is adjacent over hypotenuse. So who's adjacent to C? Well, since 15 is opposite from C, forget that. 39 is my hypotenuse, so that's going to go in my denominator. And that means the adjacent side must be this 36. And these do have a common factor. They have a factor of 3 in common. And dividing out that 3 leaves us with 12 over 13. So make sure you give me that fully reduced answer. Okay, and then there's just more. I'll do these a little bit faster because hopefully you're catching on. But if we're finding cosine of C, then we still just want adjacent over hypotenuse. So for C, 15 is opposite. This is adjacent. This is hypotenuse. So we just want 8 over 17. And I can see that does not reduce, so I'll leave it alone. For tangent of A, we're switching functions. We're not talking cosine, we're talking tangent. So this is going to be opposite over adjacent now for tangent. And we're talking about being opposite from A, so that's the 12. That's opposite. Then we want to be adjacent to A. That's this guy. That's adjacent. And the guy we don't want to use at all is this guy. That's the hypotenuse. For tangent, just ignore the hypotenuse. So we're going to do 12 over 35. And that's it, right? 12 is divisible by 2 and 6 and 3 and 4. But 35 is only divisible by 5 and 7. So that's it. And lastly, tangent of X. Opposite from X is 36. Adjacent to X is 27. And you can probably see that those are both divisible by 9. So 36 divided by 9 is 4. And 27 divided by 9 is 3. So a somewhat interesting thing for me to tell you is that sine and cosine will both always be less than 1. Always. So if you ever see a fraction where the numerator is bigger than the denominator, well, that would be bigger than 1, and that can't be right. You'd have to go back and double check. It means you probably put the wrong side in the wrong place. Okay, it could never be greater than 1. Tangent, however, it can be greater than 1 if it wants. Okay, it doesn't have that same limit. Tangent can be negative, all that good stuff. For us in geometry, is it ever going to be negative? I don't think so. So for geometry's sake, I'll say it goes from 0 up to infinity. It goes up and up and up forever. So kind of anything's possible with tangent. I mention that because if you look here, we did get a tangent here that's greater than 1. 4 over 3 is greater than 1. Now if that was your answer for cosine or sine, you'd throw that out. You would know that that was wrong. Okay, just a little tidbit for you. That brings us to this. This is the same deal as what we were doing before. But what we were doing before, we were just asking for one trig function of one angle. And now we're asking for all the trig functions of both angles. We're asking for angle A and we're asking for angle B. But it's just an exercise. Just run through it as quickly as you can. So for A, sine, we know we want opposite hypotenuse, so 7/25. Now for tangent of A, I'm going to stick with A. We want opposite over adjacent, so 7/24. And then cosine of A would be the adjacent over the hypotenuse, so 7/25, or 24/25. Okay. Now we switch to angle B. That's this guy up here. So now opposite is 24. So for sine of B, it would be 24/25. And for cosine, the adjacent side is now 7. So that'll be 7/25. And for tangent, the opposite is now the 24. And 7 is adjacent. So you get 24/20. You get 24/7. All right, let's do the rest. So for this one, they want the tangent of A. So that'll be opposite over adjacent, 9/12. But dividing both of those numbers by 3 gives us 3/4. Now for cosine of A, again, still A here. Adjacent is 12, and hypotenuse is 15. So 12/15 seems fine, but we can reduce it. Dividing by 3 gives 4 over 5. Let's just get the last A problem done. So we'll skip down here to sine of A. Sine of A wants to be opposite over hypotenuse, so it'll be 9 over 15. I'll reduce. Both get divided by 3. I'll get 3 over 5. So there's all the functions evaluated at angle A. Now let's evaluate at angle B. Starting with sine and looking at B as my reference angle. If I want opposite over hypotenuse, that's going to be 12 over 15. Divide by 3, you get 4/5. Now I'll do tangent of B. Cosine. Cosine is adjacent over hypotenuse, and if we're focused on B, then 12 is opposite, so 9 must be adjacent. And of course 15 is still the hypotenuse. So dividing by 3, you get 3/5. Okay, now we'll go to tangent. Tangent's opposite over adjacent, so again, if I'm focusing on B, then opposite adjacent would be 12 over 9. So that's divide by 3, you get 4/3. All right, that's it. So here's another thing. You won't find this on any homework problems. And maybe I shouldn't have put it here. I think it maybe should have come a little bit later, but probably not. Or am I missing a page? Why do I feel like I'm missing a page? I don't think I am. But we got to solve some problems, right? For this triangle here, we could solve for side QR if we wanted to. I could mark this X, and you could solve for it, I hope. But what we're going to ask you to do on the quiz, I'm not sure I've ever asked you to do it before, exactly. But I'm going to ask you to solve the entire triangle. What that means is you solve for every single missing part, okay? So 3 of those parts you're already going to have. So some of that's a little silly. Like angle R is the right angle. So you just fill that in, 90 degrees. Great. Angle S was given too, it's 31. So you just fill that in. And I have to give you at least one side, or else you can't solve for anything else. So notice the side I'm giving you is RS, it's 46 inches. But okay, solve the triangle means you have to solve for all the other things, okay? Now the one thing that should be pretty easy is solving for this other angle. So I don't know, maybe I'll call that X. Forget X as a side. We're going to solve for the other angle first. I'll call it X. And to find it, of course, you know that X plus 31 plus 90, those are the 3 angles of a triangle. They have to add up to 180. So this should be easy to solve for. In fact, you know that X and 31 together have to add up to 90, because if you subtract the 90-degree angle from 180, then you know they add up to 90. That math you might even be able to do in your head, right? It's 59. But if you're showing work, then you just subtract 31 from both sides, and that's where your 59 comes from. So okay, we're a third of the way done. We just have to find these other sides now. So I don't know, the opposite side I'll call Y, since we already found X, and the hypotenuse I'll call Z. So let's see. If I was solving for Y, then I would do so using the 31-degree angle they gave me. Y is opposite from that. And then the other side they gave me, the 46, that's my adjacent side. So again, taking a look at SOHCAHTOA, we have to decide whether sine or cosine or tangent is the right choice based on the information that we've got. So looking at sine, you can see that sine has to use the opposite and the hypotenuse. And so that seems good for a second because we are trying to solve for opposite, but we don't have the hypotenuse. Hypotenuse is Z down here, so we can't use sine. What about cosine? Well, cosine wants us to use the adjacent, and that's good because we have it, but again, it's asking for the hypotenuse, which is a side we just don't have. So we can't use cosine either. So hopefully tangent's the one that does the trick. Let's see. For tangent, we use opposite and adjacent. Opposite's the side I'm looking for. Adjacent's the side I have. So clearly tangent is the winner here. That's the one we have to use. So we'll write a tangent equation. We'll say the tangent of our angle is going to equal a side divided by a side. You never have to write what I'm writing, by the way. You'll just plug in. I'm just writing this to remind everybody that the way these equations work is you take the tangent of an angle. So the 31 is going to go in here because that's our angle measure. Then you're dividing two sides. Now which two sides and in which order? Again, that's where SOHCAHTOA comes in handy. The TOA is telling you that tangent is equal to opposite over adjacent. So the order OA, it's in order on purpose. It's telling you that the O is in the numerator and then the A goes in the bottom. So opposite we said is Y, adjacent is 46. So here's our equation. And we said to solve it, just typically throw this over 1, cross multiply. So I get Y times 1 is Y. I don't know why I had to think about that. Then 46 times tangent of 31 is 46 times tangent of 31. That's literally the answer. So how do I get to a decimal? Well, if you've got a graphing calculator, it's really easy. Where's mine? Hold on. Should have had this ready. Here it comes, I think. Got it. All right, so you should be seeing it now. How do I move it? It was pretty much good where it was. All right, here you go. So for you guys that are still kind of new to this, remember one thing you got to do is right away just hit mode and make sure you're in degree mode. And notice that I'm not in degree mode. Radian is highlighted. So I'm going to hit down, down, over. I need to, oops, I messed it up. But highlight the word degree and then just press the enter button down here. That'll get you into degree mode. And once you're in degree mode, you shouldn't have to mess with it anymore. But make sure you're in degree mode or you'll get the wrong answer. And so now, to find the 46 times tangent of 31, you just type it. You go 46 times tangent of 31. And you hit enter. And there's your answer. Now, by the way, I don't even actually have to hit multiply by. You can just hit times, or you can just hit tan, and it knows to multiply. I'm going to type the 31. I don't even have to close the parentheses. This is fine. You can be pretty lazy with it, and it'll be okay. But I'm getting 27.6395. 27.6395. I'll get rid of this. Okay. All right, and so your final answer to me, I'm going to want you rounding to 2 decimal places. So think of this as money, $27.63. Or should it be $27.64? It should be 64, right? Because the 9 is bigger than 5. So when the next number is 5 or more, you bump it up. So your final answer to me should be 27.64. And then we got one more side to solve for. So that was QR, 27.64. Those are inches. So we got to solve for Z now. And this time notice that if we're solving for Z, I would use the 31 they gave me, I would use the 46 that they gave me, and then I'm after this as my hypotenuse. So ideally my equation would be the one that uses adjacent and hypotenuse. And this time, that's not tangent, that's cosine. So to solve for Z, we want to use cosine. So you write an equation where the cosine of the angle, which is 31, is equal to the adjacent side, which is 46, divided by the hypotenuse, which is Z. So a little something different happens this time when we cross multiply, because in the previous problem, our variable was in our numerator. So when we cross multiplied, we got y times 1 equaled 46 times tan 31, And then all we had to do is figure out what 46 times tan 31 was. This time, though, when we cross multiply, we'll get 46 times 1, which is 46, but then that's equal to our variable z times the cosine of 31. So we haven't even solved for z yet. We still have one more step. We have to divide both sides by the cosine of 31. That'll get it to cancel on this side. And over here we'll get 46 divided by cosine 31. So it turns out z is actually going to be 46 divided by cosine of 31. Even though y was 27, or y was 46 times the tangent of 31. Sometimes you multiply and sometimes you end up dividing, just the way it is. So again, and I didn't explain this perfectly in the last problem, but if we go to our calculator, pull it out, I meant to talk about how to do this problem if you don't have such a great calculator. But for now, let's just do this one. Again, it should be easy. I'm just going to literally press 46 and divide by cosine 31. I can just type it all in, hit enter. I'm getting an answer of 53.6651. So that means z equals 53.6651. That's what I'm hearing in my head. Is that really what it was? Yeah, 53.6651. Fine. So again, if you round off, you do have 5 or above, so you do bump it up. So your answer for z would be 53.67. And then throw that in the box for me. And do remember to say inches. All right, so there you go. So now, I wanted to show you guys another calculator. This calculator. If this is the kind of calculator you've got, then you have to press the buttons a little differently. First of all, how do I even clear? You got to clear. But you guys can see that we wanted to do 46 divided by cosine 31. Well, you can't. You can't do it. Because this one, if you press cosine, it takes the cosine of whatever is on the screen. It doesn't give you a cosine and then you can enter what you want. It'll just take the cosine of whatever's on the screen. So to do this, you'd have to type the 31 first and then press cosine. And then that's the cosine of 31. But now, how do you divide 46 by that? I guess you just have to remember this number. Now that's what the M's are for on these old school calculators. It's memory. But I'm not going to even mess with trying to teach you guys that because I don't really know how to do it. I mean, I do, but I don't think I want to try. I'm not going to try. If I'm you guys, I'm just going to jot that number down, right? 0.8571 is enough. You only have to memorize like 4 of it. So let's call it 8572. So now you'd have to say, okay, well now I'll clear everything. 46 divided by 0.8572. And now you can get to your answer of 53.66. Well, that's not good. Alright, my bad. Well, this is okay. This is just telling me that I should be lenient if you guys don't round off perfectly. Because I thought I used enough of my degree, of my decimal, I mean. But I would round this to 53.66. And the answer I'm expecting is 53.67. So basically, if you guys are off by a decimal place here or there, I need to just let it go. Okay, don't worry about it. No big whoop. Alright, let's get this calculator out. Well, maybe just leave that calculator up. Let's move on. Bonk. So we're moving on now to these word problems. This is a completely different homework assignment now. You guys had homework on, so now I do think I'm missing a page. I might have to go back. You know what? I'm just going to end this video here. We'll make the word problems its own video anyway. And then if I'm actually missing a page, I'll fix that. I don't think I am though. I'm not sure. There's page 2. No, so I am missing pages. I'm missing 3 and 4. All right, so that's fine. That means this is the end of the video for pages 1 and 2. I'll make a new video for 3 and 4. I'll make another video for word problems. All right, so you guys can tune into all 3 or none or whatever one you need. Anyway, I'll see you guys Tuesday.